All right, here we go. Today is Monday, September the 22nd. Is today the official first day of fall? Was it yesterday?
I think it's today.
It's today? I think it's today. I think it's today.
Yeah.
Anyway, happy fall. That means that we're actually closing in on the end of the first 9 weeks, which is hard to believe that we've been in school already this long. Okay, but hey, that means that we're almost a fourth of the way through, and you're almost juniors. And so, wow. But today we're going to start in on a new unit. This unit is really the introductory unit to chemistry. But the chemistry teachers, we decided we wanted to do all of the measurement stuff first, get it as a foundation, and then I wanted to get the energy stuff kind of initiated, so as we go through and talk about these different things, we have a foundation to talk about, and we didn't have to stop and take a pause and do the metric system in between talking about atoms, elements, molecules, compounds, and all that kind of stuff. So this needs to be something that we kind of go through quickly. Now, part of that's going to be on me, because even though we're supposed to go through it quickly, I tend to still, there's so much stuff in my head that I just feel has to come out, and I end up taking longer than it needs to, just like I'm doing on this introduction. Okay, so let's get out the notes that I gave to you on Friday, okay? And we're just going to begin looking at that and going through some of this stuff very, very quickly. So right off the bat, we can look at the definition of chemistry, which we should already know since we're like almost 9 weeks in. But somebody read this for me. Who'll read it? Go ahead, nice and loud.
Chemistry?
Yeah.
The study of the composition of substances and the changes that substances undergo.
Okay, stop. Okay, so read it one more time loud. Right, just get to that point.
The study of the composition of substances and the changes that substances undergo.
So what do you mean, the study of the composition of substances? What does that mean? What's it made up of? Okay, and then the changes, what is that talking about? What do you think that changes that substance undergo? What does that mean? Say that again.
Chemical reactions.
The chemical reactions. That's the fun part. That's the part we all want to do. Okay? Now, it consists of all of what chemists do and what they learn. So obviously this is not just a theoretical subject. This is a do subject. And so that's the part that you like. We've done a good number of labs already. Just trying to do something and learn from what we do. For us right now, we're just doing stuff and trying to learn the stuff that's already been, figured out. But as you get into higher level research, then you're trying to figure out stuff that hasn't been figured out yet and trying to figure it out. Okay? Now, just real quickly, there are really probably more than this, but there are just 5 main divisions. What's organic chemistry? What's this? What goes in that blank? What do you think? What is all life based on? We are blank based life systems. So we are cellular, but the cells are all made up of one common element, carbon. We are carbon based. So organic chemistry is the study of carbon based compounds. This is my college textbook for my sophomore year, Introduction to Organic Chemistry. It's a very thick, big book, and this is just simply an introduction to organic chemistry. My wife loved organic chemistry so much that she took it 3 times. Okay, it took her that long to kind of get through it. Okay, it's a very, very, very challenging course. Okay? A lot of memorization in it. It's a sophomore level course for any chemistry major, any chemical engineer, any pre-med major. Okay, it's the study of anything that's, where anything that is living or was once living is going to have a ton of carbon in it. You're going to just study all those compounds. Inorganic chemistry, the study of everything else. The study of everything else. All the inanimate stuff. You know, what makes a table solid? Why is air a gas? You know, what's going on? Just the study of everything else. So what do you think analytical is?
Graphs.
Huh?
The graphs.
The drafts?
Like graph.
Oh, the graphing things? Yeah, but go back to the original definition. What part of the definition do you think analytical chemists deal with? Do what?
Changes.
Not the changes. Think about the other part of the definition.
Composition.
The composition. They analyze it. If any of y'all watch NCIS with Abby Shudo, you know, any of y'all watch that? Nobody watches NCIS anymore. Anyway, it was a big show at one point, and it's still on all the time. But she was the forensic chemist, and you know that when they would go to a crime scene, they'd bring stuff back, and she would have to analyze it and figure out, okay, what was the stuff on the bottom of that guy's shoe? Okay, what was the little residue that was left at the crime scene? Have to analyze the composition of the substance. Okay, that's what a forensic chemist is going to be doing. They're going to be analyzing all of the different data and trying to see what's in it. What was it? We have all kinds of instruments now to help with that. Now, physical, any of y'all seen Oppenheimer? You at least seen Oppenheimer, the movie? Thank you. All the guys that worked on the atomic bomb, they were all these physical chemists. This is a combination of chemistry, physics, and calculus all rolled in, and high-level chemistry, high-level physics, these are the geniuses, guys, that do this. Very theoretical. They want to know what's going on the smallest part of matter. How does it all work? Okay? We're not going there. Okay? That's way over my head. There's a class called PChem you take as a junior, as a chemistry major, which I took. I had to take 2 semesters of it, and it was rough, especially since I didn't have as much math as I needed to have in order to be able to be successful in it. And so, these are your brainiacs. This is your Einsteins, your Oppenheimers, your Niels Bohr, and all those guys. And then what do you think biochemistry is the study of? The study of the composition and changes in composition of living things. Living things, life, whatever you want to put in there. So what do you think a biochemist also has to be very well versed in? Biology and what kind of chemistry? Organic chemistry, because all life is organic chemistry. Okay? So those are just different things, but you know, we'll just see the different things. We're pretty much studying inorganic here. Now, just real quickly, the scientific method, there really is no scientific method. It's really just a very broad thing, but there's a couple of things that I just want to point out. All science is based on observation. You're thinking Newton sitting underneath the tree. Apple technically falls on his head. I don't think that story's true. Okay? But he does notice that everything's falling down. Everybody else has noticed everything's falling down, but Newton's curious. Why does everything fall down? So he made an observation. Everything falls down. Nothing falls up. So then he goes, all right, well, let's just try and figure this out. And I don't even know if he developed a hypothesis first. He just went around trying to figure out, and he came up with some conclusions. Now, this is what I used to think that a theory was just a thoroughly tested hypothesis. Not what we have that, but there's a difference between, I should say this, I thought a law was just a theory that withstood the test of time. But the reality is, a scientific law results of a wide variety of experiments, but it only describes, so underline that part, only describes a natural phenomenon. Only describes a natural phenomenon. The law of gravity, laws of motion. Laws describe while theories explain. Newton could explain, he could describe the law of gravity. The force of gravity is equal to the gravitational constant G times the mass of one object times the mass of the second object divided by the distance between them squared. And so he could get the law of gravity, and we can figure out how much gravity is. We go to the moon, we know the moon's 1/6 the size of the Earth. So what does that mean about gravity on the moon? 1/6. We can measure it. So that's laws describe it. But why is there gravity? Why, if I take this pen and this pen, there's actually gravity pulling these two together. But because I've been working out, I can resist the gravitational attraction between these two and keep them from coming together. Okay? Now, the reality is the gravitational attraction between these two very small objects is very, 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 very little. Okay? So, but there is gravity between these two. But why? Why would these two things just naturally attract? Really, nobody knows why. It's what we call one of the four fundamental forces. One of the fundamental forces it's a force that just is. We don't know why. It just is. Any two objects, there's gravity between them. There just is. Laws describe, theories explain. Kind of all kinds of theories trying to explain gravity, but there's none that are really there. Okay, so I just want to point those things out. And then just two different definitions here. Pure science versus applied science. Which one do you think is the number one? It acquires knowledge for knowledge's sake. It's neither good nor evil.
Pure.
That's your pure science. Why do we go to the moon? Why do we spend all the money to build rockets to go to the moon? Just curiosity. To go where no man has gone before. Okay? Is the moon really made out of cheese? Is there a man in the moon? Man on the moon. Is he in the moon? Man on the moon. Okay? We just wanted to know. The craziest example of that was one of the guys that lived in my dorm. He was a senior when I was a freshman. We had to live in the dorm at my college. You couldn't live off campus. But his senior research paper had something to do, I forget the title, but the part of the title was determining the rectal temperature of a hibernating nude mouse. Something of the rectal temperature of a hibernating nude mouse. Now, I mean, who in the world, first off, the mouse was probably already a little insecure and self-conscious about being nude, not having any hair, okay? Secondly, he was just trying to take a nice winter's nap, and then he had to have the temperature taken in a very uncomfortable way. Why in the world would we need to know that? That's just science for the sake of science. Okay? Science for the sake of science. Knowledge for the sake of knowledge. Who cares? Okay? Neither good nor evil. However, applied science or applied chemistry uses that. That's what we call technology. Now that's the one that we have to make decisions. Okay? We can split an atom and it releases tremendous amount of energy. Now we can use that energy for nuclear power plants, generate electricity for society in a clean, it doesn't put any greenhouse gases into the air, and no emissions really at all. Or we can use that same splitting of the atom to create an atomic bomb and destroy the world. Okay? We have to make decisions on how we're going to use science. Okay? On a more practical or more maybe relevant. What do we do with cannabis? Is it illegal? Or can we use it for medical purposes? Where the big debate, on, should we use that, mind-altering drug for, medicinal purposes, or is it really mind-altering and is it really bad for you? Where there's all kinds of debate on what we should do with cannabis. Now, I personally have my view. I think that there's better ways to treat things. I've just seen very negative effects of drugs in my family's life, but that's a debate that society is making. There's all kinds. That's just a smidgen of, all the different things that are going on. All right, so that's just some basic stuff. So now let's get into what we know as matter. Nice 6th grade. I don't know. When did you first define matter? 3rd grade? Okay. It's been so long I can't even remember. But it's anything that has mass and occupies space. And we know that there are three phases, or more, three phases of matter. Okay? Solid, liquid, gas. I mean, that's nothing new. Oh, drop the mic. Oh! Okay? But what are some of the properties? What are the properties of a solid that you learned in 3rd grade, 6th grade, 8th grade? Okay? What do we know of some of the properties of a solid? What do we know about shape and volume and all that?
The shape is defined.
So it's got a definite shape. What about a volume?
Yes.
Okay? So is the volume of this thing going to change? No. Because so it has a definite shape and volume. I should say that solids have a definite shape and volume. Okay? What else? What else do we know about solids? Are they close together or far apart? The atoms. So what does that mean? So that what, Anderson?
They're more dense.
Okay, they have a high density. Okay, again, to make everybody knows, we already did a density lab, but what does that mean, high density? What does that mean about the atoms or molecules in a solid? Are they close together or far apart? Close together. So are they as close as possible? Can you push them any closer in a solid?
No.
What do we call that term if you can't push them any closer? What do you call it if you try and press them together? Condense it, kind of the same term. Okay, if you want to push it into a smaller space, you want to compress it. So if it can't, can a solid be compressed? No. So what's the opposite then?
Expand.
Okay, it's incompressible. Okay, now if you needed to define that, okay, what does that mean? So what would the definition of that be?
Not able to be compressed.
Yeah, well, I know, without using the word compressed, cannot be squeezed. Why is it incompressible? Why is this incompressible? Why can't I push this? Why can't I push it? Why can't I push it any closer together? Because why?
It has a definite shape.
Okay? It has a definite shape, definite place, but they're already right next to one another. You can't push them any closer if they're already touching, right? So it's incompressible, means can't be pushed closer together. I hate squeaky markers. Okay? Yeah.
Okay. So, is that like fully true? Because if you had like, you could like run it over like a truck, you could like compress it further. Like, how's that like?
Well, what are you going to compress further? You're not. I mean, like when a train, we used to put pennies on a train track because I lived out in the country and there were trains going by all the time. Okay, and the penny would flatten out, spread out, but it's not. You can't make it the atoms get any closer together. Okay, you can change their shape, maybe metals because they're malleable, you can change their shape, but you can't push them any closer together. What happens, so if I was to draw a picture, of a solid, what would it look like? If I let that be an atom, where's the next atom going to be? Right next to it. Okay? Right next to it. Right next to it. But we're going to find that it's going to be in an orderly arrangement. Anyone know the term for something that's in an orderly arrangement? Organized. A repeating pattern, but there's a term. Most are crystalline. Crystalline means the atoms or molecules are arranged in an orderly, repeating pattern. This is a model of a diamond. Each black sphere is a carbon atom. You can see that there's a repeating pattern. There's an organization to it. It is crystalline. Okay? Anyone want to know the opposite of that? Okay, or non-crystalline, you know, but there's a word that means without shape. Very good, amorphous. Where did that one come from? Okay, amorphous. That means without shape. Okay? Coal, the atoms are just arranged amorphously. There's no pattern. There's no. So some are amorphous. Okay, this is the opposite. Okay, it's the opposite. So crystalline and amorphous are what's the word for, not synonyms? What's the antonyms? Yeah, I knew there's. I wanted to say homonyms, but homonyms are the ones sound alike. Antonyms. Okay? So, this is a solid. What do we know about a liquid then?
It has no definite shape.
No definite shape. But what about its volume? Okay? But has a definite volume. So if I accidentally knocked over Fallon's Stanley Cup here and it all went spilling out, if there was 8 ounces in there, is it still going to be 8 ounces even though it's spread all over the table and the floor?
Yes.
Yeah, because the molecules are still going to want to clump together. You know, they may have this puddle over here and this puddle over here, but the total volume is still going to be the same. But they take the shape of their container. Okay? They take the shape of the container. You know all that. You may not even need to write that down, but you know, they take the shape of their container. What about their density? What about their density? They're going to be more or less dense than a solid. Okay? Generally less dense than a solid. Okay, so now if I wanted to draw, and if I went and drew it based upon how you were taught in 8th grade or so, how would I draw it in here? How's it going to look compared to this one?
It's going to look like more spaced out.
A little bit more spaced out. So you're going to want to say it's going to look more a little bit like this. Okay, now is it going to be orderly arrangement? Is it crystalline or amorphous? Just kind of amorphous, you know, they're just kind of be everywhere. Okay, but we're going to think that they're a little bit more spaced out, right? But another property of liquids are that they're incompressible. They're incompressible. So what does incompressible mean? If this were true, could they be pushed closer together? If this were true, could they be pushed closer together if there's space in between them?
Yes.
This is not true. And I'm sorry to say that most of your 8th grade, 6th grade teachers taught you incorrectly on that. Okay? Because the two things don't jive. They don't mix. They can't be spread out more, but yet still be incompressible. Most of you got here either in a car, maybe you're driving it, hope maybe you have your learner's permit, okay? Okay? Some of y'all have your license, okay? Others may have ridden the bus, but no matter what vehicle you came in, I pray it had brakes. Okay? Now, how do brakes work? Okay? Okay, you know, most of y'all have seen, at least on a bicycle, you have the little hand brakes that have the little rubber things that go against the tire and stop the tires, and that's how you brake on a bike. Everybody know what I'm talking about on that? Okay, they just push together. Well, your car basically stops in the exact same way. You push your foot on the brake, and then that energy gets transferred to the wheels, and you have brake pads and a rotor, just a thin piece of metal that's about that thick and made out of iron, and then brake pads just push against it. Well, how does the energy get from your foot to those brake pads? Okay, pressure. But how does the pressure get from your foot to the tires? Well, hydraulic. What does hydraulic mean? Not water, but have y'all seen the movies? Have you ever seen the movies where somebody cuts the brake line? And then for some reason, they're always ended up on a country road, and it's always hilly. They never get stuck like a red light when the brakes go out. They're always on this mountain road going downhill, and they can't stop, and then they crash and go over the cliff or whatever because they cut the brake line. Well, what does that brake fluid do? The brake fluid, because it's incompressible, when you push on the brake, that same pressure then pushes through the fluid all the way out. It's the equivalent of pushing on a piece of metal. Like if you ever saw a go-kart has a brake, but it's attached with a piece of metal to the back, to the brakes. Well, the fluid is much easier to manipulate and move around, so they can hide the brake lines, and they can change any direction and move them around, and so they can get around the engine and all that, so they can design it any way they want. But that pressure is going to get pushed all the way down because liquids are incompressible. That's how all hydraulics work, based on the fact that they're incompressible. Now, if you end up getting some air in your brake line, well, that's trouble because gas is compressible. So you press on the brake and nothing happens because you're compressing the air instead of the liquid transferring the energy down. So liquids are going to look, and I'm going to give you a picture of this, but liquids are going to look more like this. They're going to be all just kind of still amorphous, but they're just going to be still touching one another. So why are they less dense then than solids? Okay, so if I take like wax and I melt it, it's less dense than the solid. Well, same mass, what does that mean about the volume? If it's less dense, D equals M over V. D equals M over V. If the density goes down, what does that mean about its volume? Okay, think about a math. Is the mass going to change if I melt a piece of wax? It's still the same amount of wax, right? Mass stays the same. But if the density is getting less, what does that mean about its volume? It's got to be getting bigger, right? As V gets bigger, D is going to get smaller. But I just said they're still touching. Well, how do you melt wax? You heat it up. Heat them up, speed them up. So the molecules are going to be moving faster, so they're going to be vibrating more. So the wavelength of that vibration, for a solid, they're just doing this. But for a liquid, they're going to be doing this. So yeah, they're going to be taking up more space because the vibrations are going to be bigger, longer, but they're still right next to one another. They're still incompressible. Okay? That is an important misconception that I want to kind of fix inside your head. Okay? That this is not true. Liquids are still, the molecules are still right next to one another. Another characteristic is that they're able to flow. Able to flow. What does that mean? What happens in molecules? When you're pouring water, why does the water flow? Think, again, I want you to think small. I want you to, Honey, I Shrunk the Kids, get down onto the molecular level, okay? You've never seen the movie Honey, I Shrunk the Kids? Well, probably when you're like kindergarten or about, whatever's probably when it came out, maybe even sooner than that, earlier than that, I mean. Okay, just get very tiny. Think of it like this. Think of a pickle jar full of marbles. And I go and I pour the marbles out of the pickle jar. How are the marbles going to come out? They're just going to kind of roll over one another, right? And then just kind of flow out, kind of like a stream as you pour them out. Well, that's what's happening when you pour a liquid, like a glass of water. You're pouring a glass of water. The water molecules are just rolling around one another because they're no longer held rigidly into their definite shape. The molecules can roll over one another, so they have the ability to flow. Okay? They have the ability to flow. Now, what do we? So they have the ability to flow, and then are they crystalline or amorphous? Amorphous. They have an amorphous shape. And that kind of comes, they take the shape of the container, so this is really kind of in the same lines as that. So now, we go to a gas. God, time flies when we're having fun. So in terms of the same definitions, what do we say about a gas? Shape and volume. What do we know about the shape and volume? No definite shape, no definite volume. Okay, they expand to fill the container. Whatever container they're in, they're going to expand to fill it. Now, here's kind of a mind-boggling. Mind-boggling. This is going to be something that, hey, I'm so glad I came to school for today. If you have a helium balloon, if I have that helium balloon, the helium is going to fill the whole space of the balloon. But if I pop that balloon, that helium then is going to fill this entire room. It's going to expand to fill the container. Then if I open a window or open a door, the helium is going to go out the door, out the window, and it's going to expand to fill the atmosphere of the earth. But not only that, gravity doesn't hold helium in, so the helium expands out into the uttermost parts of the universe. You know what that means? Have any of y'all breathed in helium and talked funny? Y'all all done that? Y'all know what I'm talking about? You breathe in helium, makes you talk funny? Yeah? Some of y'all are looking at me like you've never done that. I need to bring a helium tank in here. We all need to try it at least once. Okay? Okay. You would enjoy my talks here if I was talking the whole time with helium voice. Okay? But if you go and you breathe in helium and then you start speaking, hello world, how are you doing today? That helium is going to come out of your breath, out of you, and it's going to expand to fill this room. Then you open the doors and the windows, and it's going to go to expand the Earth's atmosphere. But because it can't be held in the Earth's atmosphere, your voice, your breath, your helium is going to go to the uttermost parts of the universe. So at your 8th birthday, if you had a helium balloon and you breathed it in and talked funny, who knows, that helium breath could be somewhere out by Mars or, Pluto by now. It goes, your breath, your words go to the ultimate parts of the universe when you speak with helium breath, helium voice. That's kind of crazy. Okay? What about the density? What about the density? High or low density? Very low density. What does that mean about the molecules? Very spread apart. Okay? Very spread apart. Can a gas flow? Have you ever been to a play and seen the smoke come on over the edge of a stage? Okay? Matter of fact, when I did my demonstration at the very beginning, that brown smoke, I can kind of pour it out of the top of the graduated cylinder. So gases can flow because the molecules can roll over one another. Ooh. Now here's a term. Vapor. What's the difference between a vapor and a gas? Is there a difference? Are they synonymous? When have you heard the term vapor? Water vapor. Everybody hears water vapor. Okay? Does that mean vapors are just a wet gas? Assuming water is wet? Okay? Have you ever heard the term vapor used in any other sense other than water vapor? Okay, a lot of y'all are going to be getting your license. You again, hopefully, if you have your permit, you learn how to put gasoline in the car. Okay, we don't just say, "Dad, go put gas in my car for me, please." Okay, you put gas in the car. You have to learn how to put gas in your car. Okay, but if you ever look at the warning label on the gas pump, it says, "Warning: gasoline vapors are harmful to your health." Any other term for vapor? What's the most obvious one that you guys are all thinking about, don't want to say? Nothing?
Like a vape.
Like a vape. Okay? Why do they call them vapes? Okay? Why do they call them vapes? Why are you vaping? What goes in a vape? Do you put vapor into a vape? Okay. Hopefully you guys really don't know, because I pray that there's all kinds of research coming out saying that vaping is just as bad or worse than smoking. Okay. People are trying to use it as a substitute for smoking, but there's all kinds of research coming out. Y'all find a different vice. Bite your fingernails. Drink Diet Mountain Dew. Okay. Find a non-harmful vice. A more socially accepted vice. Okay? Vaping is not one of them. What do you put in a vape? Somebody just said. A liquid. Have y'all ever heard of Vicks Vapor Rub? It's for medicine. You put it on your chest, but the menthol eucalyptus, the menthol evaporates and you breathe it in and it clears out your congestion. What do you think a vapor is? Okay? It's a substance, not just a gas, not just a liquid. Since Vicks Vapor Rub, what do you put it on as? A solid. It's a substance that although in the gaseous state is normally what? Okay, a substance that although in the gaseous state is normally liquid or solid at room temperature. Okay, now a gas is like carbon dioxide, oxygen, nitrogen, things that are already a gas at room temperature. But anything that's normally a liquid or gas, you know, rubbing alcohol is evaporate, acetone evaporates. Acetone's a liquid at room temperature, but you'll have acetone vapor, alcohol vapor, water vapor, Vicks vapor rub, gasoline vapor. Okay, things that are liquids or solids at room temperature but turn into a gas, we call those gases vapor. Now, once it's a gas, it's going to be the same as a gas, but it's just what is its state normally. Okay, that's the difference. All right, now we got 2 minutes here. I got 2 more blanks, but I thought there were only 3 phases of matter. What's number 4? A plasma. Anybody know? We've heard the term. You guys all can say it, but what is a plasma? What's a plasma?
Is it 100% blood?
How do you know?
It's different. Maybe see if that's 4. That might only be. See if that's 4. See if that's 4. I think it's 5. You only got 2? Okay. So, when we look at this picture, what's unique about the plasma? It's a mixture, it's a gas that's made up of charged particles. Now it's only going to occur, so that's the definition of plasma. It's a gas composed of charged particles. A gas composed of charged particles. Now, it only exists at high temperatures. You need to put that in there as a also. Only exists at high temperatures. A gas composed of charged particles only exists at high temperatures. All right. Now, it's the high temperatures because these are electrons. The negative things are electrons that get knocked off. So at high temperatures, like a lightning strike, or even in this fluorescent light bulb where there's high energy electricity going through it, it knocks the electrons off of the atoms. Well, electrons are negative. Normally positive and negative equal one another in an atom, but if you knock the negative off, that leaves positively charged atoms, and then the negative electron cloud going all, instead of being in the cloud, they're just free floating. So it's a gas composed of that. This is what causes the aurora borealis in the northern lights, is that it's a plasma in the atmosphere. Okay? Only occurs at high temperature. So we don't normally consider it a normal state of matter because it's not under normal conditions going to form, but it is definitely a state of matter. Now there's actually a 5th one, and there's an article in Classroom. It's short, it'll take you 5 minutes to read, but I need you to read it before class tomorrow. Okay, that's your little bit of homework, like 5-minute read the article. Okay? All right, you guys have a great day and go Jags.